All right, today's lesson is on solving rational equations. So last week we learned how to graph rational functions. And this time we're going to have rational functions that equal to another rational function, creating a rational equation, or sometimes just set equal to other numbers. So just recap, we could solve anything by graphing. So here I got an example of a polynomial function, a cubic polynomial set equal to a number. And we could solve by graphing by simply graphing the left side of the equation. So in red over here is the negative x cubed plus 2x squared plus 3x minus 2. And in blue is the negative 2. And so you could just see where they cross. The points of intersection are the solutions, the x values. So negative 1 is a solution, 0 is a solution, and 3 is a solution, this equation. So graphing is a very good way to solve any type of equation. Again, sometimes technology is helpful because sometimes the equations are hard to graph. Graphing does have limitations. In the past, the limitations are it doesn't show imaginary solutions, and the irrational ones are always rounded, so they're not exact. So we will be starting off this unit or this week solving rational equations by graphing. So we have f of x and g of x. So f of x is this rational function. G of x is this linear function. We want to know when they are equal. So we need to graph both. Okay, so if we can recall what we learned last week about graphing rational functions, I want to graph f of x. So I'm going to factor it. I want to identify any zeros, any points of discontinuity. So obviously the top cannot be simplified, so it just stays x plus 3. But I have a quadratic trinomial, so I'm going to use the quadratic pattern to factor. And I just have to think of what multiplies up to 6 and adds up to 5, and that's going to be positive 3 and positive 2. All right, so if I simplify that, it's going to be 1 over x plus 2. All right, so that means I'm going to have a whole at negative 3. And when x equals negative 3, and if I plug negative 3 back in, right, it's actually going to be a whole at the point negative 3, negative 1. All right, I'm going to have a vertical asymptote at negative 2, whatever makes the bottom 0. The vertical asymptote is at x equals negative 2. Since my exponent is larger on bottom, I'm going to have a horizontal asymptote at 0. So at y equals 0. And so let's go ahead and draw these asymptotes on here. So I've got a horizontal asymptote. I've got a vertical asymptote. All right. I don't have any x-intercepts because it's just a constant on top. The top is always 1. I'm going to have no x-intercepts. I know I'm going to have a hole at the point negative 3, negative 1. All right. If I plug in 0, I'm going to get 1/2. If I plug in negative 1, I'm going to get 1 over 1. Okay. So just sketching this out. Got a point there. All right, and then this one will be coming this direction with that hole right there. And then when g of x is 1, so I'm going to that's just a horizontal line. Okay, so if I make my line red for this one, here's g of x. And so if I want to solve that, the point of intersection, okay, which is at negative 1, right? So when does f of x equal g of x? When x equals negative 1 is the solution here. All right. So again, this one graphing worked out nicely. All right. It happened to be a nice rational number that I could find. All right. So that's how you would solve by graphing. Now again, graphing's not always that easy. All right, but let's try another one here. And so oops, what happened? Submit that. Okay, so now it says use Desmos to solve this. So if I come over to my Desmos here, and I've already have it pre-typed in here, so I got it here. And so now it's equaling 2x plus 5. All right, so here's my graph. All right, so if I grab a little shot of this, okay, where, okay, do these cross at? All right, and so they're going to cross at, looks like negative 1.5 and at negative 3. All right, let's just double check that. Click on it here. So negative 1.5 and negative 3. All right, so again, I'm not going to take the time to graph it right now. Okay, but my answers, okay, that I got here were negative 1.5 and negative 3. All right, again, I got that from this graph right here. I graphed the left side, I graphed the right side, I looked where they crossed. All right, so the x values of where they crossed. All right, so when you're solving rational equations, we need to watch out for extraneous solutions. All right, because we could do all the algebra right, all right, and it may not work. Why may the answer not work? Because if you guys remember all the points of discontinuity on a rational function on the graph, we have holes, we have vertical asymptotes. If the function doesn't exist, if the value is not part of the domain, it cannot be a solution. All right, and what happens when we're doing algebra is things will cancel out, like we saw in that last problem. The x minus 3's canceled out, or the x plus 3's canceled out. So it went away, and then we're able to get other answers. So we need to always check our solutions with the original one. So if you look at this example here, they do all this work, and they end up getting the answer x equals 2. All right, and they didn't make any mistakes, but when they plug 2 back in, 2 is a vertical asymptote here. All right, so it is an extraneous solution. It's not part of the domain. So that's one extra step with rational equations, is we always have to check to make sure our answers work. All right, the ones that won't work are what make the original equation 0 on the bottom. So you just check with the original equation. All right, so I did not do that on the last problem. Okay, I did not check our solutions. All right, so if you remember, we got the solutions x equals negative 3, right, and x equals negative 1.5. Okay, do both solutions work? All right, and so we need to plug in negative 3 into the bottom. Okay, and so maybe it's easier to factor this, which we've already done. Okay, so if I just factored this bottom one more time, right, it's going to be x plus 3, x plus 2 on the bottom. And so negative 3 won't work and negative 2 won't work. All right, and so one of my answers was negative 3. So negative 3, even though it shows it on the graph here, because remember Desmos doesn't show holes, so it still showed that as a point of intersection, although it's not intersecting anything there, because on the red graph, it doesn't exist. It's going through a point that does not exist. So the graph kind of tricked us there into thinking that it was a solution, but we had to go back and check. All right, so if I were to type this in here, all right, do both solutions work? Okay, no, only negative 1.5 works because x equals negative 3 is a hole in the rational function. Right? It makes right? It makes the denominator 0. I mean, that's it. It's a whole, I should just say it's a point of discontinuity. All right, and so we can't have a point of discontinuity be a solution to a rational equation. All right, so we've always got to check our work, even when we're solving graphically. All right, so the simplest type of rational equation to solve is a proportion. You guys have been doing this since Algebra 1, but you did a lot in geometry. If I gave you two similar shapes, a triangle, any kind of polygon, any similar polygon, you can find the missing sides by studying up proportions of corresponding parts of the shape. So, and how did you solve proportions? We just taught you to cross multiply. All right, so here you can see in blue, right, you got x plus 1 times 3. And then you have in red here 5 times x minus 3. So we just have to distribute, all right, and solve the equation using the rules of algebra. Whatever you do to one side, you do to the other. And you can see x equals 9. I don't have to check that one because notice how there's no variables in the denominator. So any answer will work right there. Okay, there's no restrictions on the x's on this problem. All right. So again, how do you solve proportions? We just cross multiply. All right, so here we have a proportion. Again, a proportion is when it's just one fraction equaling one fraction, a ratio equaling a ratio. So to solve for this one here, okay, we are going to cross multiply. So we have 3 times 2x. And again, I'm sure some you guys could probably do this in your head, equals 5 times x minus 4. Now I just have to do the multiplication. So I get 6x equals 5x minus 20. I'm going to subtract 5x from both sides. 6x minus 5x is just x. So x equals a negative 20. And I don't have to check this one for an extraneous solution, again, because there's no variables in the denominator. So my domain was all real numbers to start here on both the left side and the right side. So I know all my answers will work there. All right, so again here, solve and check. So on this one, I'm going to have to check, all right, because I have x's on the bottom. So if I get the answer x equals negative 4 or x equals 0, then that's going to be an extraneous solution because that makes the original problem 0 in the denominator. All right, so if I just cross multiply here, again, this one I'll do a little bit quicker. I won't show all the work. Negative 1 times 3x is negative 3x. And here I've got to FOIL this. Okay, so I'll actually show that. X plus 4 times x plus 5. If I FOIL that out, excuse me, my sloppy handwriting there, that's x squared plus 9x plus 20. All right, and then I got it's a quadratic, so now I'm got to set it equal to 0 to solve. So I add 3x to both sides. And so I get x squared plus 12x plus 20. Again, all I did to do this was I added, let me change colors here, I added 3x to both sides, and I just lined it up with my like term. Okay, so 9x plus 3x, that's where I'm getting 12x from. All right, and now I just have to factor to solve. You could use the quadratic formula if you want, but this one's factorable. What multiplies up to 20 and adds up to 12 is going to be x plus 10, x plus 2. So my answers are negative 10 and negative 2. And so as I said earlier, only negative 4 and 0 would not have worked. So both of those answers work. All right, so solve with your teacher. What would be the only answer that would be extraneous? So right here on this one, okay, 0 would be that, because 0 is the only thing that makes the denominator 0 here. But look at this one. This is not a proportion, and it's normal way that we see it. Now I can make it a proportion by adding these two together. They do have common denominators, so I could simply add this left side together to make it one fraction, right? And then we have a ratio equal a ratio, and we could cross multiply. All right, but there's another way to solve this, and I call it clearing the denominator. It's just making the denominator go away. All right, since they're all common denominators, it's very easy. If I just multiply both sides of the equation by 5x, okay, it's going to cancel out with everything because everything on the left side gets multiplied. So when I do this, okay, and again, I'm going to show a little bit of all the work here, right? I'm multiplying, and once you get the hang of it, you don't have to show all this, but you're going to multiply the left side by 5x. You're going to multiply the right side by 5x. So I like to put parentheses around it because this 5x has to get distributed. So it's actually going to cancel out on both of those, right? And then this 5x cancels out there. So the denominators are like they're not even there, all right? When they're all common, right, they just all kind of cancel out because I'm multiplying both sides of the equation by that denominator, all right, by that common denominator. And that gets the denominators to all go away. So at this point, I'm just left with 2x minus 1 plus x squared minus 3x equals x plus 7. Right? It's like they're not even there. The only thing I have to remember is that, right, if I get 0 as an answer, I know that's extraneous. So I'm going to combine all my like terms on the left side here and put it in standard form. So I get x squared, then 2x minus 3x is negative x, minus 1 equals x plus 7. And I'm going to set it equal to 0 because it's a quadratic. So I'm going to subtract x from both sides. And at the same time, I'm going to subtract 7 from both sides. All right, and I'm going to get x squared minus 2x minus 8 equals 0. And so can I factor this? Yes, I can. What multiplies up to negative 8 and adds up to negative 2? So that's going to be x minus 4 and x plus 2. And so I get two answers. I get x equals 4. I get x equals negative 2. And they both work. Again, the only answer that would not have worked was 0. All right, so boom, there we go. So again, all right, if I have common denominators, I'm just going to clear them by multiplying both sides by that common denominator. All right, and so this work that I'm showing, okay, shows you how, but you could just cross them off for ease sake. If you know they're going to cancel out, just go ahead and draw a line through and just worry about the numerators. All right, so here's one, okay, so very similar. So I'll try to just tell you what I mean, right? I know that these are all going to cancel out. They're like it's not there, all right? But I do know that if I get x equals 1 as an answer, right, because that makes the denominator 0, then that's not going to be, all right, that's not going to be an answer. I got to make sure I understand that. All right, so now I just have to solve this top part. Now this is a little bit tricky. This is a very common mistake. All right, this minus sign you need to make sure you distribute that. Okay, so when I'm combining like terms on top, I get 3x squared minus x squared. That's just 2x squared. And then this is a common mistake. A lot of people are going to put 9x, but it's actually 5x minus 4x. So it's x. All right, so that's a very common mistake. Make sure you distribute that negative. All right, so it's 5x minus 4x. All right, now I'll get it's a quadratic again, so I get it equal to 0. So I'm going to add 2x, that gives me 3x. I'm going to subtract 5, so that's minus 5 equals 0. So again, I'm not showing all my work in this video, but I'm just moving things to the other side, or I'm doing inverse operations. Right? So I have a quadratic here, so I would like to try to factor that. Again, if you don't like that leading coefficient, you can use the quadratic formula. That will always work. All right, so I need to go ahead and go -1 here, +5 here. It's got to multiply up to -5, and then -2 plus 5 is +3. So I get two answers. X equals -5/2, and x equals 1. All right, but as I said earlier, okay, x cannot be 1. All right, so this is not an answer. Okay, only -5/2 is the only answer for this problem. X equals 1 is an extraneous solution, does not work. All right, so here we have another rational equation, but now I don't have common denominators. All right, so I have a couple options here. I could, if I wanted to, right, I could move this over here. I could subtract it to the other side because those do have common denominators, right? And then I could combine those to be 16 minus 5x over x plus 2. Then I have a proportion. Then I could cross multiply. All right, we're going to try to keep everything consistent. I want to use the clearing the denominators one. So I need to get a common denominator. All right, so what I'm going to do is I'm going to simplify this first. All right, so if I factor out this bottom part here, all right, what am I going to get? All right, so this bottom part is going to become x plus 2, x minus 2. All right, does that make sense? So I just rewrote that. Now look what's going to cancel out, right? The x minus 2's are going to cancel out. So I just have 1 over x plus 2. And now I do have common denominators. All right. And so now, just like in the last problem, I can, right, pretend those aren't there, but I've got to pay attention, right? If I get -2 as an answer, it's not going to work. So I got 1 plus 5x equals 16. This is just a linear one. This is really easy to solve. Subtract 1 from both sides. Get 5x equals 15. Divide both sides by 5. X equals 3. And so that will work, right, because it's not -2. Right? And actually, right, +2 would not have worked either because +2 made the original one 0. So either 2 or -2 would not have worked, but I got 3, so it does work. All right, so now I've got two rational expressions being subtracted and it's equal to a whole number. So I've got a couple options here, okay? At least these two are common. So it is possible for me just to combine these up, okay? Because I could subtract two fractions that have common denominators. All right, so I could make this one fraction on the left side, and then I could just do my cross multiplication because it's like 1 over 1 over here. All right, and so I could solve that way, which would actually be pretty simple in this case, but I'm trying to keep things, okay, using the same strategy here. So I'm going to teach you how to clear the denominators when they're not all the same, right? And I can't factor this out or cancel anything out. So this is like it's over 1. So if I can make this 2x minus 1, okay, that would clear, then they would all be the same and I could clear them. So I'm going to just do it in one step though. So the trick is, how do I clear a denominator when they're not all the same? Just multiply both sides by what would be the common denominator. In this case, it's easy. It's not always easy to know what the common denominator is going to be. Sometimes it requires factoring first, simplifying, right? We're going to work more on that next class period, all right? But for this class period, this is as hard as we're going to get it here. All I need to do is multiply both sides by 2x minus 1. So again, like I did earlier, I'll show the work. Okay, if I multiply the left side by 2x minus 1, okay, I'm going to multiply the right side by 2x minus 1. So again, here, it cancels out. All right, but it doesn't cancel out on the right side. I actually have to multiply together. Right? And again here, don't forget about distributing that negative. So it's negative 4x squared plus 4x. Right? Very common mistake. Okay, not to have that positive. I gotta make sure it's positive because negative times a negative. Okay, over here I actually have to multiply these together. Well, it's easy because it's just 1. 1 times 2x minus 1 is 2x minus 1. All right, but you're probably gonna have to distribute or sometimes even FOIL, okay, depending on what's over here on this side. All right, so now it's just a quadratic. All right, so I get set equal to 0. So I'm gonna combine like terms. 5x squared minus 4x squared. It's just x squared. All right, plus 4x equals 2x minus 1. All right, so I'm going to subtract 2x. I'm going to add 1. X squared plus 2x plus 1 equals 0. All right, so that's x plus 1 squared. And so just x equals negative 1. All right, and that works. So the only thing that would not have worked would have been 1/2. All right, so that is my answer. Now you guys are going to try some questions on the classic quiz. Okay, so you're going to do your work on a separate sheet of papers, type in the right answers, okay, and take that little quiz.